Okay, Good Friday, sixth graders. Let's take a look at our lessons that we're supposed to do. I think I'm going to post the week's lesson, the beginning of the week, but not put all the attachments on it. I have a lot of students that are doing the attachments before we get to Thursday's lesson. So Friday's lesson, they have that paper turned in on Monday and they don't seem to do as well. So that might be a change for next week. But I'm looking at our lessons and it just says that we're supposed to go over the answers to the questions in the book, and then we're going to do just a quick lab on metamorphic rocks. So we read all of this yesterday, and the question asks you, does rock have to actually melt in order to change form? And hopefully if you're comparing your answers, I wrote no, heat can just bake the rock, and right here it says that bake the rock. Remember, we highlighted the other day. We look at this very interesting picture of how these rocks or these layers seem like S's, and it says deformed metamorphic rock in eastern Connecticut. So looking at the question, and sometimes reading up at the top of this will help you. The rock in the photograph was once sedimentary rock. Now it is metamorphic rock. So let's hypothesize what changed the rock. Make sure your answer explains the rock's current appearance. So I wrote that pressure bent the layers into curves. So we know that metamorphic rock is rock that has been changed using heat or pressure. So I would imagine that the layers are already laid down in sediment. And let me see if I can reach over here and you could see the layers of rock, how the layers form in sedimentary rock. So let's turn the page. We read this, we highlighted this. If you went over here, it says read the text on this page, underline each sentence that describes how one type of rock changes into another. So what they were doing, if you did this, is they were helping you answer this bottom right here, that great heat and pressure can change one type of rock into another. Classify, which means to label each rock either sedimentary, igneous, or metamorphic, and then tell me whether the metamorphic rocks are foliated, and then shade the arrowhead to show which rock can form from the other rock. So I went ahead and said, well, this rock, gneiss, is metamorphic. Granite, as we know, is igneous. Quartzite is metamorphic, and sandstone is sedimentary. So if you did this part right here, you know that granite actually turns into gneiss, right? And if you read what foliated and non-foliated meant, if you're taking a look at this, it looks like there's layers there, folds, if you will. I'm going to just grab a quick sheet of paper here, and if you're looking at it and you fold it, like the word foliated, you begin to see layers. So it's not like to me, it's always a tricky question because sedimentary rock is laid down in layers, and if you see layers, then you might say that it is sedimentary, but usually after this happens, you know, sometimes it gets bent or they're uneven. So if you read and you did this little hint here, that answered this down here, and you know that sandstone turns into quartzite. And just taking a look at the two metamorphic rocks, this seems like this a little bit more, where you can see the folds. I don't know if you could see that. You could see the folds here. So that's foliated, and this you really can't. Let me get those things out of there. There you go. You can't really see the folds, so I called that non-foliated. We're going to go over here. We highlighted those names, or these main ideas, and apply it. Although marble, quartzite, and slate are all metamorphic rocks, they're used in different ways. It asks you to observe, look around your school or your neighborhood. What examples of metamorphic rock can you find? How is each metamorphic rock used? And then write your answers in the notebook at the right. So what I did was I took the words marble, quartzite, and slate. Now I could have taken the easy way saying, I don't know, I can't find it, or you could find a way to accomplish what it's asking you to do. So I wrote down all three different types of metamorphic rock. I know that slate was used on roofs of old houses. Roofs? I think that's wrong. Okay, and then marble is on countertops and figurines, and quartzite I looked up online, and it is that it was used as countertops. I think they call them quartz countertops, believe it or not. Why are chess pieces sometimes made of marble? And if went up here, what we highlighted was that the marble can be carved easily into the shapes that you need for chess pieces. So just to help you kind of review what you read, if you answered these questions, what is metamorphic rock? It's just a rock that is changed using heat or pressure. Please remember that H and P both are in the word, so hopefully that'll help you remember. Gonna come over here, identify faulty reasoning. Suppose great heat completely melts a certain deposit of rock, which then hardens into new rock. You might think that that new rock is metamorphic, but it isn't. Why not? Well, we know what kind of rock it is. If it melts, it has become magma or lava. And once it becomes magma or lava, it has started to become an igneous rock. So the rock is igneous. So I'm going to set that aside. We went over all the questions in the book, and then the last thing we were supposed to do via our lessons was we were supposed to do this little activity on metamorphic rocks. I always like to try to do a lab. So let's do, over here we have how do grains patterns compare. So I am going to do just live Mahoney, just right. Take an example here, and today's date. I always want to put that on there, and I think, if I'm not mistaken, she's in third period, but whatever period you're in, go ahead and write that down. Okay, it's always a wise idea. Don't be a blank jumper. Okay, read what it has to say up here. Sometimes it just takes a minute to read it, and it makes all of this easier. Metamorphic rocks are rocks that form when heat, pressure, or both heat and pressure change existing rocks. In this activity, you will infer how the igneous rock granite can change to become the metamorphic rock gneiss. Now, so if you don't know, you're not supposed to write IDK because it's asking you to infer. So it does say to use a hand lens. Don't tell me I can't because I don't have a hand lens. You have an option. Some of the things that you can do is go back into your book under metamorphic rock, and we were just on that page. You just did a little bit of questions about them, and you're going to go, and I'll tell you the page that you can go to is on page 116. There we have pictures of granite and gneiss. I'm also going to attach a close-up picture of both of these rocks. So use the hand lens, and I have, I'm going to call, these are two versions of granite, I guess. You can see which one has more quartz and which one has more feldspar because their colors are different. And I'm going to call this one gneiss because it's very similar and you can see the banding there. Use a hand lens to observe the texture. Now let's think about what we said texture. Texture had to deal with grain, size, shape, and pattern. Recall that, oh, well, look at that. That's the next line. Look at that. Recall that texture is the size, shape, and arrangement of minerals or other grains in a rock. Draw a detailed sketch of the texture of granite in the box on the left, and then repeat steps 1 and 2 for the sample of gneiss, which is this one. So if you're going to look at the picture, depending on which kind of granite you use, which sample, I'm going to just set it here. So I'm just going to kind of draw a chunk of rock here, and maybe I'm going to see, okay, some of this, the black mica is kind of jagged and it's rather large. I can see that. If I were to draw this one, you could see the large courses. Let me get some other colors here. So maybe I'm gonna bigger pieces of pink in here. So to me, it says granite, and I can definitely see the size of the grains that you drew there. And then I'm going to kind of take a look at that. Let's see if I can see, if you can, let me get it under the camera, that you can see sort of the lines there. I don't know, the lights in the classroom seem to. Definitely look at the pictures I add here, though. But we can definitely see those different chunks in there. So I'm going to draw, maybe if you have even, I don't have markers, I don't have crayons. Don't be one of those kids that figure out ways not to do things. Just a regular pencil kind of would work with this. This one maybe is a little bit more rounded, but I can definitely see these dark lines kind of going through it like so. So I have that, and it says, within Earth's crust, granite can become metamorphosed to form gneiss. Infer how this happens. Well, what do we know about metamorphic rock? So I think, or we could infer that the grains were melted, then let's use the word pressured into layers. What term is used to describe the texture of gneiss, and what does this mean? So remember that we had when we're talking about metamorphic rocks, you know, it's like banded or non-banded, but I think we would use foliated. Say, and you could say, what does this mean? That it, or not, let's just say it. What does foliated mean? That, not it, that the grains, or I can see layers. Do you think the minerals in both rocks are the same? It says, do you think? So you could write no, or you could write yes. You might see, I can see the black and gray minerals. If it's no, you might say, and this is just what you think, so don't write I don't know. If you could hold on 1 second. Hi, I'm making a video. Can I call you back in 2 minutes? Okay, then tell me. Yes. Alrighty, thank you. Bye. Hey, Mrs. Liptak said hi to everybody. Okay, that was sorry about that. I would write no, maybe if I was in 6th grade, I said I cannot see any, what did we call that? Was that feldspar in there? Hornblende, any pink color. So, since it asks you what you thought, I would have accepted either one of these. You only have to pick one of them. Now that we've covered metamorphic rocks, I would imagine that you know that this is true, that the same minerals are there. They've just been melted and rearranged and maybe baked a little. Okay, so I'm going to try to make a Google Meet. I'm going to attach it to this video. 6th grade, come at 12 o'clock. and from 12 to 12:30. Otherwise, have a great Friday, and we'll see you guys next week. Okay, bye.